Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. All right, let's get right to it. Today we're going to be learning how to find and simplify square roots, cube roots, and nth roots of a monomial, one single term. Okay, let's get right to it. Let's first put our mindset into realizing that finding a root of a number is the inverse operation of raising a number to a power. Okay, let's learn these symbols very well. This N here is in Nancy is for the index. And please note that the index, okay, is very, very important because the index defines the root to be taken. In other words, the index tells the reader how many of the same value you need to take out one of that same exact value. And we're going to get into that shortly. Please note that the actual symbol itself here in red is the radical sign. And please note that the A as an apple inside of the radical sign is called the radicand. Okay? Also, very important to note that if there is no index, then it is a square root. That means that the index equals 2 when it's blank. It's a square root. Now, if my index is even, okay, if my n index is even, and the radicand A then must be greater than or equal to 0. There's no choice here. Let's repeat that. If the index n is even, then the radicand A must be greater than or equal to 0. And then there are going to be two nth roots of A. You're going to have your positive root, which is just the nth root of A. And you're going to have the negative root, which is the opposite of the principal root, which would be negative A. When they ask for both plus or minus, both roots, you place both roots appropriately. For example, I want the positive root of 16, square root of 16, so that's just going to be 4. Okay? If I want the positive fourth root of 16, that's going to equal 2. How did you get 2? Let's look at the index real quick. It's an index of 4. So if we were paying attention, we know that the index tells the reader how many of the same value you need to pull one of those values out. So if we break down 16, this is 4 times 4, which is 2 times 2. And then we've got another 2 times another 2. And we're looking for sets of 4. So a 2, a 2, a 2, and a 2 comes out as one set of 4 2s. The fourth root of negative 16 is not real. Please remember that when you have an even root, you cannot have a negative radicand. It's not going to be real. And then if I go ahead and ask you for the plus or minus square root of 25, that means I'm asking for both a positive and a negative root. So this positive and negative square root of 25 is both positive 5 and negative 5, or simply put, plus or minus 5. Please remember that when A is negative, there are no real even roots of A. You cannot have a radicand A that is negative inside of a even root. Okay, let's say that the index is odd now. Okay, my root is odd. Now the radicand can be any real number, positive or negative. And there is one real nth root of either a positive or a negative A radicand. And it's denoted in the radical form of just the nth root of A. For example, the cube root of 8 is 2. But the cube root of negative 8 is negative 2. Why? Well, anytime that you have a negative inside of an odd index, it's going to come out as a -1. So that's a nice little trick to use there. Anytime you have a negative inside of an odd index, go ahead and take out that negative value. Please note that when the radicand is negative, there is only one real root for odd indexes. Okay? Now, in order to become a master of radicals in general, really recommend learning your perfect squares, which then relate to your square roots. For example, if you know that 8 squared is 64, then you know that the square root of 64 is 8. And also learning your perfect cubes, which relate to the cube roots. So for example, if you know that 3 cubed is 27, then you also know that the cube root of 27 is 3. Let's look at some radical properties. Please note that the nth root of 0 is always 0. Square root of 0, 0. Third root of 0, 0. 10th root of 0, 0. The nth root of 0 is always 0. And please note that for any real number a, where a is greater than or equal to 0, okay, if I have the square root of a raised to the second power, this square root and this power of 2 cancel out to give me an absolute value of a. And if I have a square root of a value that's being squared, once again, this square root and this power of 2 cancel, giving me an absolute value of a. Why is this an absolute value? Well, to make a long story short, whenever you take out an odd exponent, okay, from an even index, it must be in absolute value. And we're going to talk about those examples in a few minutes. So now, let's go back to breaking down radicals. When finding real roots of a number, use the index to determine how many of the same value is needed to pull out one of that value. Okay? It would be best to know that the cube root of 64 is 4. But let's say you don't know that. Let's break it down. This breaks down into 2 times 32. And that's 2 times 16. And that's 2 times 8. And that's 2 times 4. And that's 2 times 2. Okay? So in this particular case, I'm looking for sets of 3. So here we go. A 2, and a 2 comes out as a 2. Times another 2, another 2, another 2 comes out as a 2. Equals 4. Once again, it would have been way easier to know simply that the cube root of 64 is 4, but in a pinch, you can break it down and use the index appropriately. How do we determine if a square root is rational, irrational, or not a real number? Well, it's a rational square root if and only if you have perfect squares, such as square root of 9 or square root of 144. You have irrational square roots for non-perfect squares, such as the square root of 30 and the square root of 42. And a square root of a negative real number is not a real number. So the square root of -4, the square root of -15 are not real numbers. Okay? Those are what's called imaginary numbers, and we will learn those in a little bit. Let's continue. Now, when simplifying variables inside of radicals, divide the exponent of the variable by the index of the radical you're working with. The whole number comes out of the radical as the exponent of the variable, and all remainders stay inside the radical as the exponent of the radicand variable. Trust me, I'm going to explain this with examples. But please remember that when you have a square root of anything squared, okay, they're going to cancel out. And remember that it's an absolute value. Because since square roots cannot have negative radicands, all numbers and odd exponent variables or polynomials must come out as an absolute value. So let's get right to it. Let's take all this information and let's put it to use. Let's simplify each and use absolute values when necessary. So here I have square root of 15 squared. Please remember that there's an invisible 2 here. And 2 divided by 2 is 1. So this is 15 to the first power. But that's an odd exponent. When I take an odd out of an even, I must put in an absolute value. So my answer is 15. The square root of x to the 8th. Please remember there's an invisible 2 here. So 8 divided by 2, that's x to the 4th power. No need for absolute value because I have an even exponent. Okay, the square root of 3x minus 1 squared. Please remember there's an invisible 2 here. The exponent of 2 divided by the index of 2 is 3x minus 1 to the first power. That's an odd exponent, so it must be in parentheses. So it comes out as 3x minus 1 not parentheses, but absolute value. I have here the square root of negative 15 squared. Please remember there's an invisible 2 here for a square root. 2 divided by 2 is 1. So that means I have negative 15 to the first power. That's an odd exponent. So I must put odd exponents in absolute value. So this is going to equal 15. Why, Moro? Because I pulled an odd exponent out of an even index. Cube root of 27 over 8. Well, the cube root of 27 is straight up 3, and the cube root of 8 is straight up 2. If you had to break that down, 27 breaks down to 3 times 3 times 3. 8 breaks down to 2 times 2 times 2. A 3, and a 3 comes out as a 3. Check. A 2, and a 2 comes out as a 2. Check. But it's way easier to just simply know your perfect squares and cubes. Cube root of negative 27. Please remember what I had talked about earlier. Whenever I have an odd index and I have a negative radicand, let's go ahead and pull the negative out immediately. And now let's just work with the positive number left over. And the cube root of 27 is 3, so this would equal negative 3. The square root of 4.3 squared, please remember there's a 2 here, so these two are going to cancel, and that's going to be 4.3 to the first power, must be placed in absolute value, so that's 4.3. The fourth root of negative 8, I cannot have a negative radicand inside of an even index, so that is not real. When I have operations inside of radicals, please remember the order of operations. You have to first complete what's inside of the operation symbols. So this is the square root of 25, which equals straight up absolute value of 5, which equals 5. Why absolute value, Moro? Well, there's an invisible 2 here. That's an even index. And I took out a 5 to the first power. Whenever I take an odd out of an even, I got to put it in absolute value. For J, I've got the square root of 64 minus 28. That equals the square root of 36, which equals 6. I've got negative 5 times absolute value of 8. Absolute value of 81, rather, is 9. Negative 5 times 9 is negative 45. And then last but not least for this set, we have the square root of 4, which is 2, plus the square root of 64, which is 8. Go ahead and perform those operations and add them together. That's 10. Okay. Now, let's continue, but a little bit more complex. The square root of 16x to the 8th. Well, the square root of 16 is 4. And 8 divided by the invisible 2 is also 4. I have no leftovers. I am done. I didn't need any absolute value there because I did not pull out any odds from any evens. And the 4 is already positive. The cube root of a to the 6th power. 6 divided by 3 is a squared. 9 divided by 3 is b cubed. But that is an odd exponent, so I must put the b in absolute value. So it's going to be a squared times the absolute value of b cubed. The 5th root of 96, x to the 8th, y to the 12th. Well, let's break down 96. We've got 2 and 48. And I've got 2 and 24. I got 2 and 12. I've got 2 and 6. And I've got 2 and 3. My index here is a 5, so I'm looking for sets of 5. So a 2, a 2, a 2, a 2, and a 2. That's 5 2s. So that comes out as a 2. With a leftover of 3 inside. This guy here is left over. I cannot take out that 3. I need 5 of them. So that's left over. Now, the 5th root of x to the 8. 5 goes into 8 one time with 3 x's left over. And 5 goes into 12 rather, 2 times with 2 y's left over. And that's how you get that. All right, next, I have the cube root of 2/3 to the 6th power, a to the 12th, b to the 15th. Please remember that I have an odd index with a negative, so I'm going to immediately take out that negative, me personally. And then I have my 2/3 here to the 6th, a to the 12th, and b to the 15th. Okay, so 6 goes into 3 2 times. So it's a negative, then I pull out this 2/3 to the 2nd power. Because remember, I have 6 of them. I'm looking for sets of 3, so I could pull 2 sets of 3 out. 3 divided by 12 is a to the 4th power, and 3 divided by 15 is b to the 5th power. And that's going to equal negative 4/9 a to the 4th, b to the 5th. Let's go. Okay. Square root of 81 x to the 4th. Square root of 81 is 9. Square root of x to the 4th is x squared because 4 divided by that invisible 2 is 2. We're done. The cube root of negative 216 k w to the 7th. First things first, I'm going to take out that negative because I have an odd index, okay, of 3 with a negative inside as a radicand. So I'm going to take that negative out immediately. Make my life a lot easier. Okay, the 216, let's break it down. We've got 2 and 108. We've got 2 and 54. We've got 2 and 27. Then we got 3 and 9. And then we got 3 and 3. This is a cube root, so we're looking for sets of 3. So a 2, and a 2 comes out as a 2. Then a times a 3, and a 3 comes out as a 3. Times 3 goes into 7 w's 2 times, and there's 1 w left over. So we have a k, which couldn't come out because I only had 1 k, and that 1 w left over. When we put it all together, we're going to get negative 6w squared times the cube root of kw. Let's go. Okay. 4th root of x to the 12th, y to the 16th. 4 goes into 12 3 times, but I pulled an odd out of an even, so I got to put that in absolute value. And 4 goes into 16 4 times. We're done. 9 times the cube root of negative 384, p to the third, q to the fifth, r to the sixth. Well, I have a negative here, so the first thing, and it's an odd index. So the first thing, this is going to become a negative 9. Now I'm going to rewrite my radicand, but with positive values to make my life easy. So I'm going to start right off the bat by dividing 384 by 2, and that's going to give me 192. I can divide that by 2 again, and that's going to give me 96. I can divide that by 2 again, and that's going to give me 48. Then I can divide that by 2 again, and that gives me 24. 2 and 12. Then we've got 2 and 6. And 2 and 3. And we have broken it down as much as we can. So now, my index here is a 3. So I'm looking for sets of 3. So I've got a 2, a 2, and a 2. So I've got this negative 9 times this 2 that I just took out, times then a 2, a 2, and a 2. A 2 I took out. And then I've got a leftover of 6. So inside of my cube root, I've got a leftover of 6. Cube root of p cubed, 3 divided by 3 is 1. That's an odd exponent, so that's going to come out as an absolute value. 3 goes into 5 one time as well, so that's an absolute value. And I have 2 q's left over. And 3 goes into 6 two times, so that's r squared, nothing left over. When we put it all together, we've got negative 36 r squared with p, q, an absolute value, times the cube root of 6q squared. I know it seems like a lot, but I promise you it's not that bad. You're going to master it. Go practice. Thank you. Hope you learned a lot. Come back anytime. Take care now. Bye-bye.